I'd like to welcome everybody to this first session. It's the results of the call for papers. And without further ado, the first presentation is Mile Petrovic.
Good, thank you. Nice to be here. I was a little bit worried if everybody will have time to recover after yesterday's dinners and having fun. So nice to be here anyway, and it's plenty of people, so I'm looking forward to questions. My name is Mile Petrovic. I will be presenting a little bit about AI and how we work with AI in a specific project that I will show, and how we integrate openBIM into it. But what would be a presentation of AI without some animations? So this is just the first animation showing that we are pushing the boundaries as far as it's possible. And the competence sitting in this room will tell me afterwards, hopefully, how, if we are on the right track, and if this, what we are doing is completely impossible to solve. But this is a science project, an R&D and science project, owned by us as a company, but co-financed by Research Council of Norway. And we have various partners, which I will present a little bit later. But it's a very exciting project. And project is about to create, now punchline, is to create architectural correct 3D models from point clouds. So every time they said that, the eyebrows go up from other party that are a little bit known with this subject. And what was the key that motivated us to start this initiative? It was basically, how do we make real estate owners to digitalize more? How do we motivate real estate owners to digitalize more? Now there is municipalities and companies, state-owned companies that are driving digitalization, but there is other real estate owners that are mostly focused on cost and cost effectiveness and generally time, and when it is necessary to start with digitalization. So I will, by introducing the project, I will also go into the different stages of the project when we have introduced openBIM. And but to have that bold statement that we want to do something that maybe many of you are thinking that maybe it's kind of impossible right now. We have basically an organization behind it, and that organization, a pretty decent organization, I would say, for a development project. We have SINTEF, which is a science institute that was helping us to with the competence on AI. We have also an architect. We have consultancy and pricers, two companies, one working with private sector, the other one more to the business development sector. We have municipality that are providing real estate and their specification. A lot of real estate needs to be digitalized, and how to digitalize not spending a lot of money by capturing existing data using the point clouds or other means of capturing the data, photogrammetry or LiDAR, and so on and so on. And then we have a lab entrepreneur, and a lab entrepreneur is a construction company that is basically solely focusing mostly of building or renovating existing building or building new buildings. So all of us are trying to solve this puzzle that we are working towards. Now, such programs or project organization needs also a decent budget. So the budget is 2.5 million euros, and there are a lot of activities. And we started this project the 1st of February 2024, and we are planning to finish it in the beginning of 2027. So we are basically in the middle of the project. Now a lot of action is going on. We have all activities are running, and different activities require different competences. And now it's very exciting period, but at the same time, it is a challenging period. It is a lot of things that needs to be solved. And we will dig into this solvement throughout the presentation. So all this, what we have, what is the starter of it? During these sessions that I've been part of, and some of presenters have touched up on AI or automatization or machine learning, and all the answers strive towards structured data or amount of data that you need. So what we need in this project is that we need data. We need to collect the data, and the data for us is the point clouds, and we have in this project collected 1.4 million square meter of point clouds, and all of it have been modeled in different LOD, because we use the 3D models, IFCs, to train our algorithm, or AI, to perform better and better. So it's decent amount of square meters that we have captured, and basically we have captured them with both terrestrial scanner, and we have captured that with mobile scanning. Now, having the terrestrial scanner, you will have a much better accuracy, but having the mobile, you will have maybe less accuracy, but at the same time, it will be maybe enough for a project where requirements are 1 to 2 centimeters in the accuracy of the 3D model, or for facility management purposes. But again, we are trying to develop something that makes sense in the construction as well, and not just the construction of facility management need to take it, but an architect should be able to take it upon themselves. So you see a little bit the data. It's point clouds, it's 360 images, which is all mostly nowadays scanning technology have come very far. So when you're out scanning, you're collecting also 360 panoramic images. So I will come back to that. It's a very interesting subject in this project. And all of these will be somehow connected to openBIM. So it's a lot of data, and the next step is how to basically structure that data, or what is the next step in structuring it. So basically the first step is to classify all these points and classify them in something meaningful. And that can be a wall, can be a floor, window, door, etc. And when you structure them in that or in different elements, then suddenly you have something that you can work with. You can drag it further. So looking at this slide here, you will see that this is actually a point cloud of a floor plan. And this floor plan can be from an office floor plan, or it can be a school, it can be a garage. Different environment require different approach. And when learning the algorithm, these things, you need to basically understand that you cannot just learn it or teach it by introducing same office building. You need to, if you change it to garages, it will be different type of data. So what you're seeing is basically a point cloud, unstructured point cloud, which we need to structure. So we have developed AI that is basically providing and attaching a color to an element. So you have, in this case, that we basically have green for walls, and then different colors for different elements. When you have structured that in that way, next step is what can you do with it? Now we can add basically IFC elements to it, because we are using IFC to learn the algorithm. And by adding these elements, giving them more information, you can select what you want to see and unselect what you don't want to see. Suddenly, from unstructured data, you have a structured data, and this data is basically something that you can already here work with. For example, you can take the LOD 100 of the point cloud and select the elements that are required for a LOD 100, very bare in construction, more or less, and send it to a modeler, and he will have much lighter point cloud. And normally now, modelers that are working with point clouds, they are also using images. With images, more context, with a point cloud, they can use only that to focus on solely on model what is necessarily specified in the project. So already here we have a good use by just introducing these small steps into it. But what is the accuracy of the classification and segmentation? And that is the question. So we have reached very early, we have reached 93% accuracy on segmenting a full point cloud of an office building. But it has its uses with 93%, but the question is it enough?
Well, it was not for us, so we need to move on. And the next step is that how do we go beyond 93% accuracy? Well, you can introduce all these 1.4 million square meters, and that can maybe help you. But we have very early recognized that it will just help us a little bit, small 0.1, 0.2, 0.3, and that's just enough. Going further and having 2 years left, or during that time 1 year left, we understood that we need new technology. And how do we get more context to the point cloud to be able to increase to more closer to 100? Well, we introduce images. So we have a point cloud that we segment, we have control of that. Now there are images and there are technologies that have come very far with using the images. So by combining these two technologies, we are basically we are able to go a little bit further with the accuracy. So we have introduced 3 steps in this session when taking in. Before that, we used loss files, and maybe that people that are working with point clouds understand that point clouds have different files. But to be able to harness the 360 images, we need to use another file format which has embedded pictures in the point cloud. So basically programming the AI to be able to take all this data. 2 algorithms start immediately to work. One is working through the point clouds. We come up to 93%. And other algorithm were based on SAM, meta, basically, where you segment objects in the picture. And whatever happens in the pictures is projected back to the point cloud segmentation algorithm. So by introducing the pictures, we have been able to learn the algorithm being more effective and accurate. Very interesting situation. And by using this, we have increased to 95, a little bit above 95%, or a little bit above 95% accuracy in the final point cloud. And this is a completely automatic process. Now, coming to 95%, the question is it enough? Well, it wasn't for us. So we introduced second step. The second step is a manual process. So basically a step back, working with all this and introducing a step where you need to manually click. First, what happens is that a point cloud is open. You have a look at the point cloud, it's segmented already above 95%. Then you start looking at things that needs to be segmented even better, or classifying the segment. You need more accuracy into it. Then what happens, you're looking at the point cloud, you have a possibility to press on the point cloud. Wherever you press, for example, a pipe or a door or stair, the closest picture will open because it will register the closest picture because these pictures are registered in the point cloud. And you will be able, on the pictures, click more or less to segment further, closer to 100%. And me saying this can be a little bit confusing. I have a movie showing this in action, and this is from a test environment for us. So you have a picture here, and you take this is proper way. You press on the picture, it automatically projects, and you can increase, decrease, make sure that you are closer as possible to 100%. You can click further. Everybody that have worked with SAM methods or CLIP or these methods understand how this technology is basically working. We are just trying to use this technology to increase the accuracy. And by introducing this step, we are very close. We are above 99%, but we are not at 100. The question is it possible to go to 100? We are very close. And but the question is that the optimal way working with the science project? Well, no. And that now is the punchline for step 3. And step 3 is basically everything that you do in step 2 is learning the algorithm to be better. So more clicks in step 2, less clicks later. So we are thinking that after we are done with this project, when we have gone through all the data, 1.4 million, we will remove step 2 and 3, and we will open for only point cloud classification without necessarily introducing the pictures, because E57, the embedded pictures, are much larger files. And when working with this, you need to think not just all this fancy thing, you need to how to scale the servers, how to work with CPU, GPU, and these things. And these things are also a complete new subject. I think that you can sit a half an hour just discussing these things when working with AI. So, but Unfortunately, I don't have that time, but if there is a question on this subject, it's very interesting for us to hear your opinions on it later on. So basically, these steps, we are currently working with step 2, or we have implemented step 2, now we do the trials of it, and then we will start introducing step 3. That too is working, but we need to connect them somehow, and that's also a challenge which we need to embrace. Now, all that structured data, all that steps that I've shown, segmentation and classification that have increased to 100%. Now we have already started to see, is it possible to extract more information from the IFC that contains this information by implementing BSDD? Because if we implement it here, it will help us a little bit later when we are going and building a 3D model. Or we will need it to implement it later. But if we do it here, can we extract information that for not model required project from just looking at the segmentation? And I mean, we map all IFC classes. We are already in it because we use IFC to teach the algorithm to perform. But we are also checking, like I said, BSDD already now. We tried too much, so we need to go back and try less. So now we try less, and we are introduced IDC for a checker to check how did the segmentation algorithm perform and what can it improve on that basis. So that's also a very interesting topic. I will come back to that a little bit later. But looking at all this fancy talk about how things are working, now working for Research Council and having some demands from them, working with an institute like Sintef, 4,000 employees, working only developing in different areas of research. These folks, they are working with numbers. You cannot just present something that looks good behind me. You need to produce some evidence for it. You need to publish some papers on it, and these papers need to be evaluated. So basically what happens is that we have done that, and we are, on the left side you see the accuracy, on the bottom line you see revisions of the algorithm, and we have just selected these elements that you saw before, and by looking at these elements, at 10 minutes yet, oof, I need to speed up. So we can basically measure the performance of the algorithm itself. And these performance make us either do better or do less. These 90, if you segment a slab to 97%, then the question is where have the remaining 3% went? And how can you affect that with augmentation, for example, or other types of impact to the solution? So we have developed a sub-algorithm to check how the performance are on the algorithm performing segmentation. And that's a very funny story. Why I'm mentioning that is that from that sub-algorithm, they're checking and giving us feedback and saying our slab is 97%, and these 3% have went to the walls and other elements, then we understood that, okay, we can maybe move forward and we can develop as-built analysis concept. So this is something that works. It is in our pipeline. We work with this. Basically, you segment within 5 minutes a building of 10,000 square meters, and you will see that it shows you deviations. So instead of putting down 10 to 15 minutes of your time, or 10-15% of quality assurance, you will just have an algorithm running it through in 5 minutes, and then you will manually check everything that it shows. So it increases the possibility for us to be even more effective when producing 3D models from point clouds. Here is a missing door. Same situation on the other side, that the corner have been missed completely by the modeler. And the question is, what is this? Yeah, the algorithm recognized this as some object that should have attention, but the people that have modeled, they have modeled correctly. It's not part of it. So the question is, when we have implemented BCF here, but the question is, this BCF basically is creating so many things, so it's a challenge for us to tackle. So we need to go back and see how can we structure BCF data, automatic BCF data, to be able to be more effective. Well, we are, to move further with classification, we take the second step to 3D modeling. We are classifying into categories. The first step, we have divided this step with the 3D modeling 4 steps. Second step, that we automatically generate the floor plans. And then we are adding more information to the floor plans, rules, regulations, Norwegian standard, Swedish standard, and so on, BSDD. And then we are just building up a 3D model based on IFC. Our focus is IFC. But the project directives are native files. And that too is a separate subject. So let's move on to be able to generate RVT or PLN files to another time. But that's a project objective in this case. So where are we? We have looked into deep learning. I mean, we are using deep learning all over the place in this project. But in this case, it's not time for it. We have looked into mesh modeling. It's not time for that either in this project. But what we are doing, our method, these 4 steps, is very transparent. It's architectural logical. And it is basically, we can add BSDD, we can add EDS, we can add things that are making it more adaptable. We can add a Norwegian standard, we can add Swedish standard, we can add other standards to it. And currently we are at step 3. We have managed to produce floor plans, and we have managed to add some rules. At the same time, we are working with LLMs and VLMs, natural language and material requirements or material information. And we have 2 scientists working solely on that subject. The goal is 3D model, architecture 3D model by following openBIM standard. So IFC, already mentioned that. We are working with that in the beginning. IDS, we are already working with that in the beginning of the segmentation. BSDD, mentioned them many times. And BCF, we have our spin-off AI as built algorithm. So the final is that all this line that I now said is that an LLMs and VLMs that we added is basically, we have information. So why can we not just ask the algorithm to how many windows do we have? Do we need to generate a 3D model to answer these questions? We have already segmented. We can calculate by segmenting everything how many windows. So dependent on the economy in the project, you can basically ask and you can receive it. But the next question, can you generate all these windows into IFC? Then the algorithm starts working. So different step, different necessity, or different necessary in the project will give you the answer that you need. And it will maybe suggest by including EDS to it. Yeah, this is not correct, but here is options that you can choose from. And you can implement it. And this is based on dragging a drop of point cloud to an environment where you can work further on. And then the possibilities are completely beyond just architecture. It is that we can calculate how many materials. We can add how much volume. By just segmenting everything, we have a space which we can harness. And that space we can introduce, say, Norwegian standard for 3940, which is measuring area in the space. And it's just not flat area. You need to have some rules for renting area and so on. So, yeah, that's everything that I said. I think hopefully I didn't go too much over time. No? Oh, perfect. So the thing is, what this is that we know where we are. We know that we are doing something that maybe with a lot of competence in this field and other fields, especially IFC, are maybe very aware of the difficulties by working this way. And we know the difficulties. Last week I was on the BIM World in Copenhagen, and after my presentation, the people came up and just said, good job, keep on. But in this audience, I'm hoping that people will come forward and tell me a little bit more than good job. What can we do better? What do we do wrong? Is there any improvements? Because the competence is in this room. And for us to reach out and get this competence, we have the partners, but all of these partners have their own agenda as well. And we need to have a little bit broader input by maybe you guys that have been here and have something to contribute. So I don't know if you don't have time for the questions, I will be here around. So just come up and ask for it. Anyway, thanks for the presentation. Thanks for having me here.
Mila, you have 3 minutes if you want to take any questions or feedback.
Any questions or feedback? Oh, already.
Yes, to what extent is the general, especially when you mention accuracy of data and reliability of the outcome, when I don't know if reliability is somewhere in the IFC schema, but I know there is something like p-set uncertainty. So for instance, do you generate p-set uncertainties characterizing the uncertainty that surrounds the object that you've generated? Or do you document the uncertainties outside the IFC set? That would be the question.
I like these very technical, complicated questions. I will try to answer that. But this, what you just said, we have not come that far. We have come to step 3. And we need to monitor somehow. And when we start working with step 4, is basically we need to apply researchers to work with it and find how things are done. Your suggestions is just an eye-opening and a door opening for us to consider that in the project. So we don't have a roadmap that we know how to follow. We have some basic roadmaps, but during that roadmap, challenges arise. And your suggestions, I will try to remember, and maybe you can send me a mail, just what, yeah, there you go, it's recorded. I didn't even think about it, so that's very good. Go ahead.
Yeah, thank you for your presentation. My question is, do you use the point cloud, the geometry reconstruction technology? You mean you use the image enhancement to make the IFC classes classified objects? So do you use the geometry reconstruction?
So it is divided in different steps. So we use the geometry in the first step, basically, because that's very easy. You have geometry in IFC, you have a geometry, something unstructured, where you can structure based on the geometry that you have in IFC. So that's the first thing. But when you add this geometry, you understand that in IFC there is more information. And how do we open this information to the algorithm to harness that and reflect it back to the, say, walls? But the question would be, how many walls will there be in the real scenario? Will this wall with IFC sees as a wall always generate as a wall, or will it give you an option that this is a concrete wall, but you may consider if it's something else? We have not decided on how to move forward. We know that we have this information, and we know that we can harness that. And we have tried it, it works. But in the real life, like the previous question, how do we measure that? How do we make sure that these things are properly? And again, so far, we have come that we are very good at the geometry. We have added BSDD for some elements. We started with many elements, and that was just broke down. So we started with a few elements, for example, walls, doors, and more information in it that it's consistent in the IFC, and working that way upwards. I hope that I answered the question, but if I didn't, yeah, go ahead. Okay, last question.
Okay, thank you. It's a follow-up question to your statement about geometry. There's a lot of geometry inside IFC, many different ways of geometry, parameterized geometry. What subset are you focusing on? And do you have any plans to devise parameterized geometry also?
So in our group, as you say, we have an architect. And this is an architect company with 40 architects working in Norway. And these guys, they have very much requirements on how this geometry should be basically working from the native files and exported to IFC. Now, we have a lot of discussions with these architects, and they have their requirements. And some kind of, it should be logical, it should be possible for them to take the native file or IFC and continue working with it, not changing, adding, and so on. So, of course, we need to consider the different geometry approaches, not only in IFC, but also in native files from the beginning. And therefore, we have some procedures which we, as a company, have developed. This is a modeling guide, how to model from the point cloud and which tolerances are acceptable or not acceptable. And how should you model things that it's just a corner, but what is inside the corner? Should it be visible for somehow, and should it be labeled with something? So we are considering that, of course. We need to consider that if the results are going to be useful. So yes, the question is that we will consider that. Thank you. Thank you very much.
Thank you very much, Mila. The next presenter is Erik Poirier from buildingSMART Canada.
Thank you. Thank you so much for the presentation. Interesting stuff. I will be presenting something slightly different around digital authentication of building information models at the object level. This is research work that was undertaken by my master's student, Mehdi Fakour. So shout out to him. And I have Stefan Joud here in the audience that's going to help me with any sticky IFC questions. So I'll start off by saying that you set out to do something as a researcher, and sometimes you fail. And this is a case where we didn't achieve what we were expecting to do. So, and sometimes as a researcher, maybe that's more interesting than actually making things happen. So this is all in a report that's now available on the buildingSMART Canada website. This was work that was undertaken with a partner, Notarius. So they are a company that specializes in digital signatures. So most engineers in Canada have their digital signature and stamp hosted by Notarius. So they authenticate identities for professionals. And this was done with also buildingSMART Canada folk, Claudia and Bill. So shout out to them. If they're online, it's 3 a.m. So I guess not. Okay, so what's the problem that we're trying to solve? If you go through the process of signing and stamping drawings and authenticating drawings, you know that we flatten our models, we create PDFs, we sign and seal them, and then we submit them for the purpose, permitting, tender, construction, shop drawings, etc. It is a very sort of counterproductive process because we're flattening intelligent models to create record drawings. And if we want to go towards true digital workflows, we need to be able to sign and seal information. Now that's simple, but how do we actually do it? So the idea is now to be able to sign and seal BIMs, but at the object level, because right now we can do it at the model level, we'll do it at the file. So we'll be able to sign and seal a file, an IFC file, but that's not what we set out to do. We wanted to say, I'm responsible for this electrical panel. I want to sign and seal this electrical panel. I'm responsible for this column. I will therefore sign and seal this column. So how do you actually do that? And this was coming from our industrial partner, Notarius, who works with the different orders. And just some context in North America, I know it's not the same everywhere, but in North America, an engineer and architect is responsible for the design that they produce. And that for a number of years, they have liability to make sure that the design conforms to standards and codes and so forth. And there's also different use cases where you'll have, for instance, in Quebec, it's the engineer is responsible solely for the design, whereas in Alberta, another province, not only the engineer or the architect will sign, but also the company has to sign. So you'll have multiple signatures on an object. So these are the types of elements that we're trying to deal with. One of the things is that these are secure and legally binding models. They're contractual, so they have to be robust. It has to be something that we can test and make sure that they're valid. And we have to have trust, transparency, and accountability throughout the process. So 2 questions that were laid out. What are the requirements and functionalities of an ideal solution? So we sort of projected what would be the best possible solution we could create if we had a magic wand and reality was not a constraint. What are those? And then the other one is, well, how can we actually implement this? So we did say, here's the ideal situation. And this is where I said we failed. We said there's an ideal situation, but we can't achieve that with the current technologies. So what can we do to hedge our bets? I'll go quickly here. My intent was to, I'm with a educated crowd, and I wanted to start debating the potential of IFC. So I wanted to get into an IFC discussion. That's why Stefan is here to help me. So authentication, what does that mean? You have different ways of authentication. Everybody has Authenticator on their telephone, and you two-factor authentication and stuff like that. There are different ways to authenticate identity to show that you are who you say you are. What we use currently in the industry, when you sign and seal, digitally sign and seal or stamp drawings, you'll do certificate-based authentication, and that means, it's a digital certificate as an electronic evidence that verifies the ownership of a public key. So an engineer has a key that is in a database held by Notarius, and it authenticates, says it's an engineer, he is who he says he is, or she is who she says she is, and she is an engineer in that province. Or a state or wherever. And there's two certificate authentities, so X509 and XADES. So we don't have to reinvent that. That's a standard that exists. Certificate-based authentication exists. We don't need to reinvent that. Data integrity, so we followed the Alcoa Plus or the Alcoa Plus principles of digital data integrity. I won't read them, but these are basically the foundations of data and information quality, if you're recognizing them. So making sure that data is, attributable, legible, et cetera, et cetera. We also looked at the MOL as a legal deliverable. That's an initiative that's led by the Department of Transportation in the US, where they are actually delivering projects using the model as the legal document, which is a huge step forward. So they're removing paper from the process. Now, we looked at that and said, well, what are the mechanisms that they have in place now to make sure that the models that they're using are the right models and that they're signed and sealed by engineers? And so they're going towards a memorandum base. So all the IFC files are listed, and the engineer will sign and stamp that memorandum. So it's a way to do things, but we have an issue when we want to get into more granular and modifications at the object level. So it's a great step forward, but we have to go further than that. And so we also looked at what are the requirements for digital delivery based on the MOL as a legal deliverable document framework. Of course, everybody that asks, we talk about this, everybody says, yeah, what about blockchain? Yes, blockchain. Blockchain is great, blockchain is fantastic, but blockchain, sometimes you don't need a bazooka to kill a fly. So using the right technology, I think, for the right applications is a key here. So why use something that's not tested, not regulated? Blockchain is new, it's exciting, but what do we know what it's going to be like in 50 years? Digital signatures have been around for a number of decades, will be around for a long time. Sort of same thing with IFC. So we compare what the difference between blockchain and digital signatures. That's in the report, and we sort of say, well, why did we go towards digital signature instead of blockchain, which is the question. So read the report. And then we looked at different solutions that exist currently in the industry to digitally authenticate, digitally sign and seal models. A lot of them are at the file level. So like I said, the file level has been managed. Either you do memorandums, you say, here are the files in my document. Here are, we have BIM chain that does that. They do blockchain, but for BIM, for IFC files, etc. So we also, of course, looked at the aerospace. Aerospace is a domain that has looked at, how do you actually certify object level elements because they're doing digital workflows. They've been doing it for a long time. So they do have sort of found solutions. They're working in more proprietary, closed systems. They don't have the same constraints. They can integrate their supply chains and make them all work in the same system. It's not really possible in the construction industry. Here's the research methodology. So won't go there. We did workshops, we did literature reviews, we did prototyping. So we did speak to the DOTs because we were very interested in the mall as a legal document framework. We then, of course, worked with software developers and different professionals. One thing that I have to say, we're not looking at the business processes, we're looking at the technical aspects. Business processes, how you sign and seal, how does an engineer actually do the work, reviewing the documents, filtering out the objects, and then saying, I will put my stamp on this, and this I certify as being true, is a process unto itself. Okay, and so we were saying we need to just figure out, is this possible and how can we do it? And we'll let the business and business owners or engineers figure out how to do it. When we're looking at what that means for an object level authentication, it means we have to have tools that allow filtering, parsing out, saying, I just want to certify this system. I just want to certify these elements. So there's plenty of ways that we can do that with, Mol UDEF MVDs and so forth. That will come up later on. So we really focused on the technical aspects. So our ideal solution. So this is, if we had the magic wand, this is the solution we would go out and build. So it enables object level authentication and integrity checks. Okay, we can do that right now with IFC. It's doable. It integrates with existing tools and workflows. Yeah, okay, let's get openBIM principles and IFC into existing workflows and tools. It aligns with the Alcoa principles and the MAL requirements, so the digital delivery. So I showed those. So far, so good, not too complicated. There's fast processing and scales to large BIMs. Ooh, okay, there we're starting to have issues. So if we are applying a signature on each object, and each object is hashed and has to go and to an external server to validate, you can imagine that when you have thousands and tens of thousands of objects, it can become quite clunky. And it supports various scenarios for accountability, shared accountability. What happens when you have two engineers signing a document? What happens when you have multiple firms? What happened, for instance, when you're doing some shop drawings, structural steel? Okay, it's going back and forth, and you have shared responsibilities for certain elements. So these are types of things that start, getting sand in the process. So these are the types of things that we were saying, let's try to figure out how we can do this. And so this is how it would look like. So you have your signing process across the top, and you have a verification process. Any process that you have where you're signing an authentication, you need a signer, you need a verifier. And so you'll see what we're doing. We created a sort of a utility MVP type thing where you would actually be able to sign each object with a digital signature. And you have your output list of objects in there, so you're able to compare two versions of a file that has been signed and saying this object does not pass, it does not conform, it is not verified. Therefore, there's an issue. You have to send it back or get the engineer to approve a change. So that was sort of where we were at. So you sort of see what's the realm of possibilities. Once you start looking at the ideal solution and you start picking away at it, you're looking at, well, what could we do? So there's essentially two branches of this solution possibility. There's the actually integrating the signature into IFC, and that's what we were hell-bent on doing that, saying we are going to use IFC, we're going to use existing containers, and we're going to get our signature in that container, and it's going to work, and it's going to be awesome. That didn't happen. So we had to go to sort of using the IFC mindset, so an IFC step file, but then actually getting the signature in there, and I'll get back to that. And this is where I'm going to go quickly, and hopefully I can get Stefan up here we can discuss around the IFC data schema base, because for me, being here today was do we propose new IFC entities to be included? And then the biggest thing is, well, what do we do with IFC 5? Can we propose changes to or solutions or things that we can do with IFC 5 and integrate that so that now that we're developing it, we get that potential to embed digital signatures directly into an IFC5 schema. So, new entity, I think that's a big process within buildingSMART. Anybody who's worked on the IFC schema development, it takes a long time. And the thing is, we sort of set out to say, well, I think there's probably a place we can use currently in the IFC schema to embed a signature. So we don't need to propose a new entity. Let's reuse an existing entity. And so that was a lot of work on Mehdi's part to first understand the schema, understand where a signature could go. And then you get into the actual functionings of how IFC works and is functions within programs. And what you see theoretically and what you see in reality is a bit different. And there's a lot of nuances and subtleties that we'll have to get into when we get there. So, we wanted to sort of reuse existing entities, map required metadata of digital signatures to the IFC schema. So one thing is that because we have existing standards, we know what metadata we need to include to actually authenticate a signature. And then find containers that includes all required metadata, can be associated to all the entities, and find a way to associate digital signatures containers to the entities. So, for instance, when we're looking at the required metadata, this is what you need when you authenticate when you create a digital signature. You need a signer information, you need a certificate issuer information, you need a certificate validity period, you need signature timestamp, and you need signature value. So these are the 5 things you need. You don't need anything else. So then we're looking at, well, where can these elements exist within the IFC schema? So then we looked at where in the IFC thing these elements could exist. So you see that table. And then we looked at different candidate containers. And this is where last year in Morocco, Marrakesh, when CIB W78, we presented these, and then we got in touch with Stefan, and he said, no, Stefan, we would look at IFC owner history and object reference select or IFC approval. And he said, we should probably add another one and do some more investigation. So this is where I think this is really valuable to present these things here and get challenged on our assumptions. So you see these where things could belong. So IFC owner history, and you have the issues lacks fields for detailed digital signature for IFC owner history. IFC object reference select. It's a select type that allows referencing various entities. And IFC approval represents information about approvals, authorizations, and verifications within a project. Now, how those get instantiated, that's where the issue sort of lies. I'm going to go quickly. This is all developed in the report. Given that I have 12 minutes left, I want to leave room to discuss. And so you have sort of essentially the conclusions of that review of the different containers within IFC to hold all the metadata for digital signatures is here. And you sort of look at, we sort of can do it, almost, maybe, but not a resounding yes, we can do it. And we sort of saw, well, probably the best candidate is IFC approval, okay? Now, how does that get instantiated? That's a question, that's another question. We also looked, of course, at, because the IFC schema is one thing, and everybody knows, there's the schema, but then there's how it gets implemented, and so you can't just look at the IFC schema. You have to look at the MVDs. And so the thing is, well, we looked at the different popular MVDs and saw which ones are actually dealing with it. And then we also looked at IDS and where does it belong to the IDS. So we're trying to cover our bases, look at different areas where we could do, for instance, IDS-based sort of validation and saying, oh, is the signature in the right place? Does this entity exist, and is it appropriate? So you can sort of see, again, IFC approval has sort of that is the best potential candidate, but only partially for the IDS mapping. So some challenges with IFC. Backwards and forwards compatibility across the IFC data schema. No, IFC doesn't have a version number. However, it does deprecate certain aspects, so certain elements when it evolves a schema. So these are things that, certain elements or certain places or entities in the IFC 2.3 schema weren't present in the IFC 4, or they were deprecated in IFC 4, et cetera. So this is an issue that we have to contend with. Of course, the MVD, if the reference entities are missing, so the whole export and the whole actually how do you create an IFC file, that's really where the practical challenges arise when you're trying to embed the signature within the IFC schema itself. Relationships in IFC schema. So this is where the complex relationships. So relationships, it's not a nice tree like you see in your browser when you're opening an IFC schema, an IFC file. It's actually complex, and the relationships are networked. So inheritance is complicated. What inherits what, and how does it? There's a lot of loops in the data structure, and we don't know where the loops end. So that was just trying to see where actually how could you select an object or a system and then put a signature and make sure that the signature propagates to the right elements in the system. Easy to say, not so easy to do in practice. We have redundant instances, duplicate data that can cause ambiguity, and optional data in elective implementation in the IFC schema. There's inconsistent data population across software tools. Okay, so that was our exploration of ISC. There's potential, as it currently is instantiated, doesn't work. We didn't suit the purposes that we had set out to actually sign and seal BIM at the object level. So what we had to do is go back to the drawing board and then looked at, well, we have the schema, but we also have the file. And right now, I understand we all want to go towards object-oriented or object-based, data-based, serialized data exchanges. But for the time being, it'll be files that we'll be exchanging. So we looked at the IFC file itself, which is based on the STEP protocol, so ISO 10303. And we looked at, okay, so how can we get the signature within the STEP file and then authenticate the objects within the STEP file? So here's what the sort of what the standard says in terms of data exchange structure. So you have a header, you have an anchor, reference, data, optional, and signature. So the signature block exists already within the ISO 10303 data exchange structure, which is STEP, which is what IFC is based on. So we said, well, it already exists. So why don't we reuse that? So that's what we did. We sort of just played or looked at the adding the signature block within the IFC exchange structure through the IFC SPF. And so this is what it looks like. So we have our IFC header. So this is when you open the file and you look at it. IFC header, the file data, you have the file signature section, and then you have signature block, et cetera, et cetera. So that's how it would look like. And that was if we were to sign each object within the file. So you find an object, you sign it. So you can imagine, like if you've ever opened up an IFC file, there's hundreds of thousands, if not millions of lines, hundreds of thousands of objects. It can blow up your model pretty fast. So we tried compression and everything doesn't work because it's already compressed to a certain extent. And of course, having these unique identifiers and so forth made it that you can't rationalize it more than it already is. So what we did is we said, well, what's the best sort of way to bridge this challenge? And going from an object, let's go to a collection. So let's hedge our bets. Let's say an engineer will probably say, I'm responsible for this system, and I will take ownership of this system, and I will sign that system. So we created basically collection level signature. So that cut, of course, if you can say there's hundreds of thousands of objects, but there's maybe 10, 20 collections within a model, then we can sign those collections instead. And so that was sort of where we landed. We tested it. We created an MVP. Basically, you upload the file. It allows you to sign it and choose what you want to sign, add your signature using the Notarius database with the hash, and basically to sign basically BIM at the collection level, okay, within the IFC file. So we see this as a sort of an intermediary step. We're trying to get towards serialized information exchange, towards data-driven information exchanges, leave file-based information exchanges behind. Now, for the foreseeable future, we're working with the professional orders in Quebec, in Canada, to try to see, can we actually get to this point where we're able to do similar to what they're doing in the US with the mall as a legal deliverable. It's a lot of discussions, a lot of politics, a lot of questions. So what we're looking at in terms of, well, this is during the verification process, what can happen, the valid signature and matching hashes. So everything is valid, signature over block is valid, all hashes are matched, no object tampering is detected, therefore the file is good. We have a valid signature, so the signing entity is good. However, data in some collections is modified post-signing, therefore it's rejected. That means it was tampered. We were able to see which collection was tampered. We're not able to go to the object level. Valid signature, previous signature block, hash mismatch. Therefore, the signature block is altered. So that means the signing entity is not good. And then digital signature block is invalid. Therefore, the signature does not work. So these are different types of ways that we can validate the file. And therefore how this can actually work. So I wanted to get here. I have 2 minutes left. What can we do with IFC5 and digital authentication? So IFC5, as we understand, and this is based on our limited understanding of where IFC5 is trying to go, where it's going, as an entity component system. So composition over inheritance, or composite reuse principle. We're looking at increasing reusing definitions, therefore facilitating adding new definitions. So this is the extensibility of IFC5, which I think is promising. There's complex information retrieval, especially following relationships and referencing. So this is one thing, is that we're looking at how to create relations and how to create models. Maybe focus should be put on how do we extract information within IFC5. So that was a question I'd be more than happy to discuss and talk about how this is possible. Also, the other thing is simplifying relationships. Hopefully we'll see simpler relationships that we can get into with IFC5. And we're looking at 2 potential avenues to include digital signatures within IFC5, either adding new containers for digital signature within the schema, or reusing existing entities, either IFC owner history, IFC approval, or so forth. So that's it. That was a lot of very fast. There's a lot of all of this is in the report, and I'm more than happy. For us, this is a way to try to get the ball rolling on this topic around digital authentication at the object level, which is inevitable if we want to go to truly digital workflows in our industry. I'm done.
Thank you very much, Erik. The next presentation is from Connect, so I'd like to welcome Jakob and Dieter to the stage.
Good morning, everyone, and good morning, or whatever time of day it is for the people online. In this presentation, we would like to present how Connect tackles the problem of complex model validation. Model validation is a necessary step to get your data to a point where it can be used for all kinds of digital workflows. And as you all know, it's a tedious job. We think that it could be, or can be, more a driver for design rather than in between time-consuming repetitive task as it is today. I do this presentation together with my colleague Jacob. He'll do a live demo in the second half of this presentation, and I'm Dieter Froyen. So let's get started. Maybe it's
maybe
good if
just quick. We have some connection issues, so we'll try to get the slides up and running as soon as possible.
Okay. Maybe I just can get a bit ahead of the slides then. Before we dive into some ideas, solutions we're working on, I wanted to take a step back in looking how our architectural design is working today, how we design today, what the architectural language we can create today by the technology we have. And as you will see quite soon on the slides, one of the technologies that's very interesting, and you see probably a lot of movies online of AI-generated architectural design, where you get really inspiring ideas of how the new architectural language could be. And this is all supported with software for free modeling, where you can create your wildest dreams in architecture. You can create really nice new geometries, really nice concepts in architectural design. And I'm talking about everything that technology is bringing to us, but we have still a little bit problems with the slides. Maybe going further on that topic. So we have nice concepts we can see, AI-generated images. We have free-form modeling tools. We have also performance calculation tools for structural engineering. So even if you have a wild concept in architectural design, it will be buildable because we have the tools to calculate the structure for it. We have architects can work with new materials. Well, it's a long list of all the possibilities we have to create a new architectural language. And then this is a perfect slide for this part of the presentation. It's not only in the design part, it's also in the construction part. So when the design is finished, okay, of course it has to be built as well. And then you see that also in construction industry, there is a lot of new technologies emerging. One of the well-known is 3D printing, allowing that complex geometry turned into reality. You have robotics for building. You have it on-site, you have it off-site. And next slide, please. But there is a but. We think that this nice opportunity is a bit hampered with the modeling tools or the software we have today. Next slide, please. So we have today, as you start on a design, you have choice between two paths. You can rather work in a free form modeling tool, or you can directly start in a more technical design tool. If you start with a free modeling tool and you have the well-known examples like Rhino or SketchUp, they'll allow you to work with your design, create the building as you want, but there will be one point where it ends and you have to get out of that environment of working in a free-form modeling tool, and you have to step to a more technical BIM tool to create your drawings, to go to a technical design stage. The alternative is to start from day one in a more technical design tool. And then we think there is the limitation is that you're working with the tools you have in that software to create your building, but you're more concentrated on getting the design created with the tools you have, and it's more like checking boxes and unchecking boxes and choosing types of objects. And it's taking you away from the design process and more fighting like with the software. Next slide, please. And it's not only that, on top of that, so you have the software tools that not allowing you a fluid design process. You also have IFC that still as a secondary export of your data. So you still have your data in your native files, and as soon as you, yeah, so, okay, thank you, then. Yeah, IFC, it's still, and we all see it as, well, that's the way it is. IFC is the way of exporting your data from your native files, but it's always with some complexity. It comes with some complexity. You have the risk of losing data. And also there we can think that there's a better way to work with. As said, you have that data loss, semantic gaps. So you have openBIM data. You can exchange your data with the rest of your team members, but it's not the best way of working. And then at last but not least, the slow validation loops. If there are some validation of your models, you see some things that you want to be corrected. You have to bring it in a feedback loop, ask the author of the BIM model to correct the data, get a new version of an IFC file, and you have a time-consuming process started to get your data as you want it. And then this is a bit the preparation for this point, that we think that all this complexity, well, it's a bit the idea of the problems of the past. We think that there are better ways, newer ways, and that BIM, as we all think, it's really complex. Yeah, well, why not try to make it as simple as can be? And we have some ideas and concepts in Conic that try to achieve that goal. The first one is the seamless data continuity. And what we mean with that is that you can start modeling in a free-form modeling tool. You can use Rhino. You can model in Conic itself from day one. And you just concentrate on the concept, on the geometry, the form, the experience of your building. And you're not forced into a way of struggling with technical tools. As soon as you bring that data from Rhino into Conic, it's already structured according to the IFC data structure. There's no data in it yet, but you can populate it with data, and it's always according to the IFC data structure. Also, if you want to export your BIM model afterwards, then it's without any export settings. It's always ready to export because it's the data as it is structured in Conic. That will be also the way it will be exported. And what Conic brings also is an online platform with anyone of your project team can collaborate, have access to the BIM models in the cloud, and all work together. So they all working with the latest version of the project, latest version of the design, and really can collaborate in nearly real time. We think that this is, yeah, democratizing the access to the information. It's really necessary to get a quick delivery of your design, and you don't have all the hassle with struggling with exchanging data. On top of that, you will be able to check your data at any time with an IDS check, or do some rule checking on, for example, fire resistant, rule checking on your regulation in your BIM model. And all of that with some nice tools to help you to speed up your work. We have an AI assistant in the background. It's a classification tool that as the design evolves, and you need to do your classification of objects into the entity classes. then we have a tool that will do that for you. It supports more than 100 IFC classes, and you get a prediction of what IFC class that object should be. We also allow natural language queries, which will open the BIM model, the data of the BIM model, also to the non-technical users. So, for example, your client, they can simply type a question they have on the project, and supported by that NLP technology, they'll get an answer quickly, and so allowing them to interact with the data of the model. At some point, maybe you want some 2D drawings. It's maybe a deliverable still. We have some automation for that. So you have your IFC model in Conic, and it's with almost like a push on a button. You get a complete set of automated drawings. I saw it also in the first presentation, so I think it's really something that is a need for. We have it quite quickly in the tool, and Jacob can show an example of that. And the last one, we don't forget the contractors as well. Is it buildable? You can have really complex projects, but you want to see how you have to build it. What's the link with the planning, the time? So we speak about 4D planning, and then we can ask Conic, give us a simulation of how the construction will evolve, how can we build it, and you can check it as a contractor, is it buildable or not. So let's show how this works.
Okay, so let's show some things here in Conic. So I want to show some of these points that Dieter mentioned during his presentation. First point being about taking geometry from basically anywhere and continuing it within the downstream process, within the further process in BIM. So in this case, we have some geometry that came in from different sources. We have some Revit models, some IFC files, maybe some geometry that was modeled in a tool like Blender, for instance, with really complex geometry, or maybe some very industry-specific geometry, like maybe, for instance, an elevator that is everything modeled entirely in 3D. The point that we were trying to make is here that we don't want to limit the functionality within Conic based on where it came from. So for instance, we have here this little pavilion, which actually was made in Rhino. So there's some 3D geometry with some nice looking roof here, but it's not actually BIM geometry. It's not data rich. We'll see if I select this door here, that it doesn't actually have a IFC classification. So this is a building element proxy because, again, it came in via Rhino. It's just dumb geometry. This also means that there's no relation between this door and the wall it sits in. So if I would move this door, you'll see that the opening doesn't actually move with it. Because, again, this is what we say dumb geometry. Conic allows you to enrich these kinds of models coming from SketchUp, Rhino, with proper openBIM data. The entire data structure of Conic is based on IFC, which means we have things like IFC classes, IFC property sets built into the product natively. So we can either classify this door as a door manually by choosing from a list of supported IFC classes, or we can let ourselves be assisted by our very own AI assistant. As Dieter mentioned, there's an AI assistant here called Conic Intelligence, which basically, based on the geometry and context, will make its best guess as what something might be. In this case, the top guess as a door, which I will accept. Now, once we've actually classified this thing as a door here, it'll behave like a door. So if I move it, you'll see it'll actually also update the door opening. So it'll behave more intelligently. We can, of course, further enrich this with other openBIM data. Let's say, for example, property sets and properties from the IFC schema for a door. So door common, I can add a fire rating, and so on, status. So I can reach existing models coming from geometry modeling tools and take them further downstream in the BIM process. So not only the data can be edited, of course, the geometry itself can also be modified. So you can take this geometry coming from Rhino or any other tool, also IFC geometry, and actually start to modify it. Of course, if you have the necessary access rights. So in this case, I'll create an opening in this roof here. And this is actually just a small demonstration to demonstrate that we can actually also handle quite complex geometry. So this is NURBS geometry coming from Rhino. We can this can be still further edited within Conic. Now let me switch to a different project here, where I would like to show some other features that Dieter also talked about. Namely, we want to democratize the BIM process to also non-technical users. So people who don't have years and years of training in the IFC schema or in a specific product like Revit or ArchiCAD, for instance, we still want them to be able to interact with these models. So in this case, we have a model that came in as an IFC file, and we can simply ask questions in natural language about this file. So for instance, what is the total area of plasterboard in building 1? So now the assistant will actually parse this question and apply the correct filters, make the calculations based on this question. In this case, we have around 5,900 square meters of plasterboard in this building 1 based on the selection it made. So that's based on this geometry. Or maybe we want to ask a question about how many doors with 1 hour fire rating. Again, it will search in the IFC schema or in the properties assigned to the objects and give the correct selection set. In this case, 307 doors with fire rating. Let's look for the fire rating property. F60, so that's 1 hour. So it correctly interpreted this F60 as a 1 hour fire rating, which matches my query. Let's take a look inside here. So Conic can also be used to do certain checks of an IFC file. So these can be things like geometric checks. Maybe I want to know, is the width of my corridor actually according to standard? So you can do some very local, in this case, distance checks. It's about 1 meter wide, which would be maybe okay in this case. Or you can do visual checks on actual properties and data in the model. Like, for instance, if I take a look at the fire ratings of the doors, I want to see visually where are the doors with specific fire ratings. I can create a sort of report showing me the different fire ratings and colorizing them. So, for instance, 1 hour fire rating doors, 90 minutes, and then apparently there's also a couple of doors that don't have a fire rating assigned. Let me color them in blue here. So there's a couple of doors that don't have this property assigned, which we can actually resolve within Conic. So again, we cannot just evaluate these models, but we can actually enrich them, fix them, to get them to the necessary level of data. Now, in this case, this was a visual check of these property values. It'll also, of course, be possible to do this in a more structured way using, for instance, IDS checks. This is currently still in development, but it allows you basically to read in any IDS files and get visual feedback as to what is missing, and then either create issues from these this missing or incorrect information, or just build in that information natively in the model at that moment. Now, as Dieter mentioned, one of the issues we also want to, one of the questions we also want to assess is whether something is buildable. So we're building in some tools also in terms of 4D simulation and planning. So I'll give a quick demonstration of that as well. In this case, again, we have an IFC file which contains some IFC data, things like, of course, IFC classes and so on, but there's no information about planning, for instance. There's no task assigned to these objects. We're working on a way of what we call visual planning, allowing you to very easily and quickly create and assign tasks to object and visually check whether these objects are actually buildable in the order it is proposed. So you can, starting from a preset based on groups and filters that you can assign based on these IFC data in the model, we can create a planning, create a first pass at this. And in this case, I have beams, columns, walls, and slabs on different floors in different parts of the building. And I just want to say, okay, I first want to build a slab, then on top of that, the column, walls, and then the beams, for instance. Once I did that, it will actually create the tasks for each type of object on each floor and allow us to quickly see, simulate how this building would actually be built. So this is just in a few seconds based on just common sense and IFC data in the model. I can actually see that there may be something wrong here. There's a couple of columns that are floating. Looks like some of these columns were actually in the wrong place during the planning. So I can actually make sure they're part of the correct work set, part of the correct building. So I can adjust data to make sure that the planning actually makes sense and the building is buildable. So based on that, I can create a new planning, I think. So it allows you to quickly iterate and check whether things are buildable. So let's take a look. This already makes more sense. So it looks like we found an error in the IFC data and rectified it by looking at this visual planning tool. This is also still work in progress, so not yet released, but we thought it made sense to show this here in the context of this presentation. And finally, based on IFC, we're also working on creating construction documentation or actual 2D deliverables from these IFC files. So basically the idea is take an IFC file, where necessary, enrich it with data or geometry, and then get deliverables out of them as well. So for instance, here we have an apartment building, which again was an IFC file with some floors and elevations defined inside the IFC file. So a couple of stories here. And based on this story information, Conic can actually automatically generate floor plans of this geometry. So for each floor, a floor plan will be generated, which can be viewed in your browser, but also edited, annotated. So it will be automatically annotated with dimension chains, things like door tags, window tags, which can then be also manually edited where necessary. With automatic running dimensions and things like door and window tags, this was all generated automatically, but again, you still have the control to manually, for example, move some annotations if they're in the incorrect place and so on. This is fully vectorized, so we can always create a DWG out of this, which can then be taken further downstream in the process. I think that was the end of my demo. I don't know, Dieter, if you wanted to say a few things still.
Yeah, yes, maybe just to end, the thing we wanted to show is that rethinking model validation, that we're working on a way to make it more supportive for designers to create your design, to validate your design. And we showed some examples where with automation, with AI, with some good tools, the designers are supported, the contractors are supported to get your design up, finish it, get your deliverables ready in as shortest time as possible. So I hope that that can be inspiring for some of you and enlighten your work. And we still have maybe some time for a question or two.
Thank you for the presentation. Very interesting demo. So I'm curious about the versioning of imported IFC files. So you showed that you can change some of the parameters of the IFC elements.
Mm-hmm.
If you get a new version and the same element comes in, do you have to change that parameter again?
No. So we, yeah, I didn't show this in this demonstration because we're limited on time, but basically there's a built-in version history for changes that happen within Conic. So every change is tracked, of course, can be reverted, can be viewed, can be compared, but that also works for external changes. If you have a revised IFC file with some new geometry maybe, or some modified geometry and data, the modifications you made within Conic can be merged together with the ones in the revised IFC file.
So you surface that to the user and they decide if they want to merge it or ignore
Sorry?
it. So you surface that you surface that
Yeah.
conflict to the user and they decide if they
Yeah,
want to merge
so
it.
indeed, if these changes are able to be combined without issue, it will happen automatically. If there are possible conflicts because of changes that are contradictory, you will be notified as a user and you can individually change them or choose which one to actually keep.
Great, thanks for sharing.
Okay, thank you very much. Thank you, Dieter and Jakob. There'll be a short break now, and we'll be back here in 30 minutes.